Okay, we're going to do a calculation in order for us to find out what the index of refraction of some unknown material is. We're going to use something called Snell's law, and for the first time you're going to have to use a trig function. It's called a sine function. Don't get worried about it. All that means is in your calculator you're going to have a sine button. And even if you don't have a scientific calculator, they have them on computer calculators, so they're easy to find. All right, what happens here is we're going to pair up anything in one medium. When you take the index of refraction times the sine of that angle, it's going to equal the index of refraction of a second medium times the angle in that medium. So the only thing you have to look out for is just make sure that the angle matches the index of refraction in this medium and that the angle equals the index of refraction in this medium. That's all you have to pay attention to. So let's go ahead and do this calculation. And I'm going to use Snell's law, n1 sine theta 1, and it doesn't really matter which one's 1 and which one's 2. And so I start, as always, with an equation. Let's start plugging in our values. In this problem, n1 has a value of 1.5. My angle is 45 equals n2 times the sine of 65. The only thing you have to be careful of is your calculator must be in degrees. So you just check your mode real quick and make sure you're in degrees. Go 1.5 sine of 45. That gives me a value of 1.06 equals, I'm going to do the sine of 65, and the sine of 65 equals 0.91 n2. All right, now once I do this, I divide both sides by 0.9, and if you take 1.06 divided by 0.91, that gives me 1.16. All right, now a good thing to do is let's look at this and see, does this make sense? Looking at that diagram, does it make sense that your N2 is smaller than N1? And I would say yes, it does, because 65 degrees is bigger than 45, which means it's going faster. It's definitely going faster in this medium. And if it's going faster, that means N2 has to be less dense. And if N2 is less dense, it would be a smaller number, which is exactly what we've got. There you go, first problem.